I am Alan Michael Grobelny, or AM for short. I am a developer evangelist here at AWS. Let me see if I can get the slide to advance. There we go. That's me. I have a background in mostly application development. So that's my primary software engineering background. I also served as a solution architect at a company called Box, just most recently. That was my most recent career before becoming whatever a developer evangelist is, right? So I've got some stories from my time at Box that I think will play really well into what I'm talking about today, which, if you saw the title slide, is Rapid Full Stack Serverless Application Development. Just really loaded it up with the buzzwords just to grab your attention.
Oh, I talked fast.
So hopefully we'll learn something together. And if you have questions, things like that.
I mean, the room's packed.
Chris
I
here
didn't.
too.
I was shocked because I'm sitting here talking about
If you have questions, I'm happy to take them.
Wait a minute.
I'm pretty
I
informal.
wanted to start at 8:50, so that.
All right. Sounds like we're good. Let's see. Well, we may have to look at my face the entire time. Nope, good, cool. So what qualifies as serverless? This is a question I often ask myself late at night, maybe 3 a.m. in the morning when I'm losing sleep, saying, what is this serverless thing? Not really. I mean, but it is a difficult question to answer, right? Everybody kind of wants to paint things either as containers, microservices, serverless. And at the end of the day, what does it really matter, right? That's kind of what I'm trying to push towards. Is it's important to know what qualifies as serverless, but at the same time, it's just another tool set, right? It's just another way to get things done, to run code. But I've got a general rule of thumb about serverless, and these are the qualifiers that I use personally. Really, 3 of these are the most important to me. One is we scale to meet user-driven events, right? So it scales with usage is what that translates to. So the more user events that take place in our application, the more our functions or our API layer or whatever we're utilizing scales to meet that demand. There are a lot of services in AWS that are built that way. Lambda's obviously probably one that most people are familiar with. The next is never pay for idle. That's one of my favorites, right? That was one of the first times that I stopped when I was outside AWS and started seriously looking at things. As an application developer, AWS, to me, was a little intimidating. There are a lot of services, a lot of ways to run code. Lambda and never paying for idle, never have to worry about managing infrastructure, which is the third. I kind of led myself into that one. Those 3 formed what became a very interesting compute platform for me as an application developer. I've also seen several other types of developers, including front-end developers, suddenly just granted access to back-end development. They don't have to worry about how to start up a server, how to manage that server. They can just write their code and deploy it and have it run, have it scale. Don't worry about pricing in terms of we have all these idle resources that aren't being actively utilized. So it really opened the door for a lot of application developers, in my mind. Now, I swear I'm going to get good with this. There we go. Just to give you an overview, I'm not talking too much about Lambda today. I actually have a pretty interesting newish service that's focused on client applications that I'm going to get into. But just to give you a background, basic way that a Lambda-driven application works is there's some sort of event source. It can be multiple triggers that qualify as an event source. So Lambda has a lot of triggers that you can set. It can be on file upload to S3. It could be on a database change in DynamoDB. It can be an API call, right? So all of these qualify as event sources. What that does is it triggers your function to run. Whatever code you've deployed to that function will execute. And you can tap into other AWS services or outside third-party services. Anything you need to do just as you would on any code that was running on a server. So that's the basics of Lambda and the basis of serverless computing. Well, I got too good with the pointer. So what kind of use cases do we solve with serverless applications? Obviously, web apps are a really great candidate for this, right? Web apps often sit idle. Web apps, depending on usage, will have points where they scale. Like, let's say you go viral on Shark Tank, and the next day your web app, or website all of a sudden has to scale to the huge demand. Backends, that's kind of a generic thing to say. Not all backends should be ran serverlessly. That's another point that I like to make. If you have a long-running process, for example, in your backend, you actually can't run that serverlessly. If it's longer than 5 minutes, Lambda will time out. So not everything should be a serverless application. But data processing is another really good way, because those are things that you don't typically want to worry about a server running or have to scale that server to meet the data processing needs. And generally, you can get what you need done if you're doing simple transforms to data in less than 5 minutes. Chatbots, and we actually have a really great chatbot service at AWS called Lex as well. Alexa skills, right? So skills are a great candidate for serverless computing and, of course, IT automation, things that you typically have written PowerShell scripts or Bash scripts to do, which, incidentally enough, PowerShell is now a target runtime for Lambda as well. So you can deploy your PowerShell scripts directly to Lambda and run your IT automation directly in Lambda as well. So these are some of the common use cases. We'll focus mostly on not necessarily web apps, but what I call client applications, applications that your users interact with some kind of device, right? Be it the web, be it their mobile device. Those are the two that we'll focus on. And as I said, this is temperamental. There we go. So serverless helps with rapid backend, but what about my client apps, right? You get the animations for free. I won't charge you extra for the animation. It took me longer than I would like to admit to get that working in PowerPoint. And obviously, I didn't get the spacing quite right here. But AWS Amplify is exactly what helps you rapidly deploy client applications with a serverless backend. So all of the services that AWS Amplify uses to hook into your client application layer all qualify under those serverless parameters that I put up front. So we'll see exactly how they do and what services we use with AWS Amplify and what it can do. But I want to tell you a story first. So at my time at Box, when I was a solution architect, I'd say 90% of my job was flying out to places a lot like Norwood, actually, and helping companies like S&P or Nationwide develop rapid prototypes of applications that they were looking to get funding for from the business, right? Software is hard to make, right? We all know software is actually really, really difficult to make, and most software projects fail before they even get off the ground. So my job was to go out, make sure that there was a good enough prototype that the development team was enabled to create so that they could take it to their C-level and get funding. That was generally 90% of what I did day to day. And honestly, much of what I did was super repeatable. It was the same services getting added again and again to these client-level applications. It was authentication, it was storage, it was an API access, but also an API that adhered to the authentication that they were doing. And these things are not trivial to do on your own. especially for application developer personas. It's not something you do every day where you write an auth layer as an application developer, but it's almost present in the majority of applications that you'll write. So let's see some of the services that Amplify works with. First off, the target deployable runtimes that we have supported in the AWS Amplify library are iOS, Android, and JavaScript, which personally, the JavaScript community right now it's a little tumultuous, right? I'll put that. That's the best way I can put it. It's tumultuous. We've got a lot of different frameworks that are constantly changing, but it seems like the dust has settled a little bit on these top three: React, Angular, and Vue.js. Right? If you want to talk about any of them afterwards, I'm happy to. We can get into that. I won't weigh in, except I prefer Angular, but I don't have any preference. Okay. Please don't come at me on Twitter about which one's better. They are all, I love them equally. They're like my children. And then React Native, obviously, is a new exciting way to write applications that target both mobile and web. What do we give you with Amplify? And we'll see exactly what Amplify translates to. It's a little, I'm sure, blurry right now, because there are actually really three parts to Amplify. But we get you analytics, an API layer, authentication. Yes?
What's the difference? Is Amplify a GraphQL as a service from AWS, but with different name?
So the question was, for those who couldn't hear, is Amplify GraphQL as a service? Is it a managed GraphQL server? Is that fair? That's a part of Amplify, actually. That's one of the categories in Amplify. So as we'll get into more and more, you'll see, I actually have a full section on GraphQL. But yes, GraphQL is supported. Really, at the heart of Amplify, it's not a new service, actually. It's a packaging of all of our existing services in a more easily digestible library and CLI tool. That's what Amplify is. It's a way to quickly add these features without having to go set up the individual services in AWS and have them automatically connect up to your application. So let's take a look. There we go. So there are three pieces, like I mentioned, to Amplify. There's something called the Amplify CLI. And this is how you actually configure your applications. So you use a very easy-to-use command line tool that allows you to add features directly to your application without ever having to sign into the AWS console to go set anything up. You can directly push and create cloud services from your CLI, as long as, of course, you've set up your profile just like you would for the AWS CLI as well. The next part is the Amplify library, available, again, in iOS, Android, and those three flavors of JavaScript and React Native. This is a way to automatically configure your client application to call out to these services. So you don't have to go and implement authentication and find the Cognito library and set Cognito. You just utilize methods from this library directly in your code. And of course, when you want to add that feature, you use the CLI to add it. You issue the Amplify push, which we'll see later on, and it creates the service for you. And then finally, there are also pre-built UI components. So you don't actually have to spend time writing a sign-in page, for example. This is a pre-built higher order component. The one we're looking at is a Vue.js component, but there are components in Angular, Vue.js, and React. And they all, we'll take a deeper look at what's available there too. And they all automatically display the UI that's pre-built. How do I get started? This is my first question anytime I hear any talk. It's as easy as installing a Node package. That's it, just a Node module, right, globally. So if you've done any front-end development in the past couple of years, a lot of that has moved on to pulling down packages from NPM, right, which is the package manager available from Node.js. They come bundled together. If you download Node.js, you also get NPM. So the CLI tool is actually just a Node package that you can utilize. And Amplify init bootstraps your project. So with the CLI, as I mentioned, you're going to configure your backend services directly from your terminal as you're working on your client application. Now, this is just some examples of the terminal output. It asks you what editor you're utilizing. It's got support for a lot of the common front-end editors. It's got what type of application are you developing, Android, iOS, or JavaScript? And then what framework, if you choose JavaScript, it'll ask that you're developing in. This is because Amplify actually comes in and learns about your build steps and will help you build your front-end application as well with common built-in CLI tools from the Amplify CLI package. And that's what we're seeing here. It asks what your source directory path is, where your build assets will go after the project is built, what actual command you run when you build. So npm run build, for example, is a pretty common one. Now, how do I actually add a feature to one of my client applications? And we'll take a look at a couple of the different features that you can add, right? So I mentioned authentication already. This uses Cognito, and it creates a user pool for you automatically. For deeper into under the covers, behind the scenes, this is, of course, using CloudFormation, right? So behind the scenes, what's happening is CloudFormation templates are generated for the services that you add, and when you utilize the amplify push command, it will go and run that CloudFormation template in your account and will create the actual services so that you don't have to worry about, did I get the CloudFormation template right? Am I using the right service? It's literally just, I need authentication in this application. I'm going to run this command right here, amplify add auth. That's as simple as it is. And then as soon as I'm ready for that to be created in my account, I will run amplify push or amplify publish. We'll see the difference between what those two do in a little bit. But this is, I don't know, we're looking at maybe 10 lines of code here. This is an example of a React app where I'm even doing manually signing in. I could have just imported one of those higher order components I mentioned earlier. Don't necessarily have to write any of this code at all. I could just pull in the prebuilt UI component, and it handles the full life cycle of logging somebody in or resetting their password or sending a confirmation code every time they log in, those common authentication use cases that we see. So if I were to build my own UI, though, there are helper methods in Amplify. So I import the auth library from AWS Amplify, and I get access to things like sign in or confirm sign in or confirm sign up. So here we go. We also have API support, and we're getting pretty close to the next slide after this is about GraphQL, so we'll talk more about that too. But this is a regular REST API that you're probably very familiar with by now. And it utilizes API Gateway under the covers. So if we look, again, it's the same command. It's all these categories that we saw at the beginning all get added through this simple CLI command, amplify add API. It'll ask you some questions too. You'll see as you utilize the Amplify CLI tool that it's very interactive. It lets you configure things through questions instead of through writing JSON or YAML. And then it generates, and you can actively update as well. So in addition to the add command, there's also Amplify update API. Let's say you made a client app, and 6 months later you need to add some more REST endpoints. All you have to do is amplify update API, select your API, and then add in the new paths that you're looking to create. That's all you have to do, and then push. So as we can see, there are also built-in convenience methods for calling out to your API. What's even cooler, and not really shown in this code, is that if I have authentication added to my application as well, I can actually make the API adhere to that authentication as well. So I can have a secured API through Cognito, and my library here, this API.get, will automatically know that it's secured. It will issue a SIGV4 signature to the header, or you can set up also JWT authentication. So either way, it's a secured API endpoint without you having to worry about how all those services got created. Yes. I'm so sorry? That's right. So the question is, does it create the API gateway for you with the API that you define out? Yes, it will. You actually are walked through, and if you notice, this is kind of difficult to read, I'm sure, but it says provide a path. And so that's where you can actually define out the REST endpoints that you want and the methods that you can use against them. So yes, it defines out the API for you and creates it with your help, obviously through the CLI tool. So it takes your input, goes, creates a CloudFormation template, issues that to your account when you use Amplify Push. And again, you interact directly with that API through the Amplify library for whatever language you're developing in, JavaScript, Swift, Kotlin. Oh, there we go. Now it's on a hair trigger. So I mentioned earlier GraphQL. So what is GraphQL? We're going to get into that a little bit. But AWS has a managed GraphQL service called AppSync. And again, setting up AppSync, you can do it from the console. You can do it from the AWS CLI. But it's a lot, for me, a lot more desirable to do it through Amplify. And what you get, there we go, is a lot of use cases surrounding real-time data. That's kind of where GraphQL sits, or data-driven applications. If you have to go collect the aggregation of a lot of data, and normally you would utilize several API calls across the board to go do this. GraphQL gives you one endpoint to go collect that data instead. So it reduces the number of calls that you're making to an API, and it supports real-time through subscriptions is what GraphQL uses for its terminology when you're actually getting data updates in real time through a socket. All right, so what is GraphQL? Kind of started to get into that a little bit. It's essentially just a standard. That's all that it is. It's a query language, right, developed at Facebook that has a standard for accessing data from, it looks like REST, but it's not really REST. You define out the object that you want to retrieve, and the GraphQL server that you're running knows how to get that object, regardless of where the fields on that object are coming from. So you can have an object that's composed of fields that come from 3 different services, for example, but the GraphQL server aggregates that data through what's called resolvers and passes that back to your UI just through one call, right? So you define out, I just need the name field, the address field, and maybe this person's social login or something. And maybe those are coming from 3 different systems or 3 different API endpoints that you would normally call. If you put a GraphQL server in front of it, the GraphQL server will resolve that data all together and send that back to your UI. You can also then, if another piece of your UI doesn't use the address, remove the address from your query and obviously save on data over the wire. Now, what is AppSync and what do you get with AppSync? AppSync is the managed server part. So you have to, as the front end or client application developer, solely write your schemas, right? That's what's referred to as the definition of the data in GraphQL. So you write a schema defining out the object that you're retrieving, and that's it. You can annotate your schemas with special annotations for AppSync. If you tell it, for example, model, that this is a model, it will store that in DynamoDB. It also interacts directly with Elasticsearch and Lambda as well. So it has automated resolvers to those 3 targets. Of course, with Lambda, obviously, you can make that a resolver for basically anything that you can get to from Lambda, which is almost anything. AppSync's other killer feature is about offline data support, right? So it syncs up data when a device goes offline. And it resolves the data conflicts automatically with some default rules, which you can also customize and do things around that as well. But you can wow. All right. Keeping me on my toes. It does not like that series. There we go. So with Amplify, what Amplify adds to the picture here is it helps you to manage this schema, right? Since you don't have to worry so much about the SQL or the GraphQL server running, since AppSync will manage that for you, instead your concern now becomes your schemas, right? And so Amplify puts in some additional helper tools with working with schemas. My favorite, personally, is the code gen. So if you go in and define out your schema in Amplify or AppSync, you can then generate either TypeScript or Flow classes based off of that. And it's just another CLI command. That's it. All right. Of course, it wouldn't be complete. The Amplify support here wouldn't be complete without its own GraphQL client as well. Just like we saw with the API client, where I could pull in that library and just do api.get or api.post or api.put. It's the same with GraphQL. So I have an api.graphql where I can issue out GraphQL queries, mutations, or subscriptions. And these are all the 3 categories of things that you could do with GraphQL. Obviously, GraphQL warrants its own presentation. It's huge, and it's relatively new, about 2 or 3 years old at this point. GitHub's a really good example of someone who has a production GraphQL deployment right now, and obviously Facebook too. But it's a technology a lot of people are betting on. So utilizing Amplify, you can really focus on the things that make GraphQL interesting, in my opinion. Now storage, this is what I worked with, obviously, when I was at Box, day in and day out. And you'd be surprised at how many applications are driven by storage. Well, I would give you some examples, too. Well, I'll just list them for you. Some of the examples are photo sharing, right? Imager or Instagram, very popular applications. A lot of the applications that I worked on personally at S&P and Nationwide and State Street, these places, are all document vaults. That's what the phrase we termed for them, where I'm a financial advisor and I need to get you some sort of PDF about your finances that was generated by a dozen or so financial analysts, but I have to do that in accordance with compliance, right, with PCI or whatever compliance layer that I'm working with. I have to have somewhere secure to store that. Amplify can give you this, right, with S3, right? So Amazon S3 is one of the oldest services. It's just object storage. I can put a file. It doesn't have to necessarily be a file. It's just a collection of bytes, and put it in no hierarchy needed, right? So I can also create an arbitrary hierarchy, which is exactly what Amplify does. let's say you want to have a private folder for a user. Amplify will create the private hierarchy for you and make it only accessible to the user that you created that for. And these are all options when you utilize Amplify's CLI tool to add storage to your application. Yes?
So you have to first send a call window. Where do you specify for this user I want this storage?
OK, great. So the question is, obviously, the user is a user incognito. How do I say that this user is equated with this folder? So in Amplify currently, when you create a private folder, it does it across the board for all users, right? But then it adheres to whatever user is logged in, whatever session is being utilized in your client application. So for example, it knows to send it to, it creates a path in S3 for each user in your application, in your user pool incognito, and then say I'm logged in as the Alan Michael user. If I upload a file through a client application, it pushes it to the path where it's private for me, and that is only accessible by that user. So all of that is automatically set up for you. You can also have, I think there are 3 different layers. There's public files, protected files, and private files. I think protected adheres more to a group. I'm not positive. I'd have to look that up. But again, look, you can actually define out the level in code that you want to store an individual file as well. So in the Amplify library, one of the options when you're doing a put against S3 or your storage is the level. So you can say this is a protected file or this is a private file. And it changes the accessibility accordingly. Let's see if I'm lucky now. The other storage layer in Amplify is DynamoDB. And in terms of storage, DynamoDB is just a NoSQL database. So it's arbitrary data that you can store about an object or about some kind of model in your application. It's just a database. That's all it is. So you create the database. There's not really much in the terms of library support for Dynamo or calling Dynamo directly. Typically, Dynamo is paired with an API gateway, right? That's the general use case for Dynamo in a client application is you put an API gateway layer in front of your Dynamo, but this allows you to create a Dynamo table directly from your CLI tool. So you don't have to leave Amplify to go in and create a Dynamo table, and then you can put an API layer in front of that. All right, so Prebuilt UI Components. This is one of my favorite features of Angular, or of Amplify. You can tell I have a predilection towards Angular. But we have support in Angular, Vue, and React for these UI components. And I'm not really that much of a UI person. So having these are really, really helpful to me personally, because especially when you're doing this rapid prototyping like I was doing at Box, for example. You just need something that you can go show, and then you can customize it later. So we've got support for an authenticator experience, for a chatbot experience, and for 2 use cases around storage. It's a photo picker or a photo album. So those are the pre-built UI components we currently have. This is just a view of what the authenticator looks like. It has customizable CSS themes as well, just as you expect with a lot of pre-built UI that you can swap in and swap out. And this is the code to add your authenticator. This is it. In JavaScript, in React specifically, it's 2 lines of code. Android, I've got a Kotlin version and a Swift version in iOS. And again, you can see how little code you're actually writing to display a full authenticator. And again, this follows throughout. It will detect if a person is already signed in based on local storage, for example, in the web. And it will, absolutely have state maintained across the board throughout this entire UI. All right, so, oh, yes?
Yes, so on the UI stuff, in regards to the chatbot, is that a user interface for Lex in particular, or is it any chatbot? Can you talk a little bit more about the pre-built chatbot?
Yes, absolutely. So the question is around the chatbot UI. Does it have to use Lex? Is it only around Lex? Fair? Is that? OK, great. I actually was going to bring this up near the end, but this is, no, it's good. I don't have a slide for it or anything. It's just something I was going to mention in passing. The Amplify team is very, very particular about the language that they use. This is actually a service built for cloud services. It just so happens that all of the cloud services that are currently implemented work with AWS, right? But it is an open source library. These services could be extended to any cloud service, essentially. We're probably not going to build anything but the ones for AWS. But as a community, obviously, we would always look for input on what other kind of chatbot experiences or services. And it's just a pull request away, too. So it's an interesting point that I think I'm going to keep my eye on the Amplify team around that, in fact, just to see if we do implement or allow other cloud services in there. It's again, throughout all of the documentation, all the language you'll see, it is a library for cloud services, not necessarily AWS. And again, warning, warning, warning. It's only AWS services currently, right? So I'm not saying that you can go out there right now and have Box as your storage layer today, right? It's not there. So this is my call to action for you all, for anybody who is interested more in Amplify. Obviously, come talk to me. Hit me up on Twitter, or I'm probably more active on GitHub or LinkedIn, but you can definitely hit me on Twitter. I'll have that information up. But where can you go today to learn more? So I made you some short links here, some little bit.ly links. This is an application I built. I call it a GIF photo booth. That's how I like to describe it. You can come in here, sign up for an account, and it will open the camera. This only works on the web, by the way, on your browser client. Probably won't work on your phone, actually, because Apple has yet to support WebRTC with HTML5. So it probably won't work well in your phone if it does at all. But if you go here, it opens your camera using the WebRTC stuff in HTML5. And you can start recording a video, and it will get transcoded to a GIF at the end. If you like what you've recorded, you can click Save Recording, and it will send it through a serverless backend that runs Elastic Transcoder to transcode the WebM file format to a GIF. All the code, obviously, is at that second link. So if you'd like to go look at the code. It's an Angular app. Surprise. This is what it looks like. And for those keen observers, I do only have one outfit. Like, that's it. You go to my closet, it's 7 of these, and like 20 of these. Oh. One more before that. There we go. Cool. So this is how you get started with Amplify in general. aws-amplify.github.io. Amplify team is very open to feedback. There's a very active GitHub repository for both the JavaScript library and the CLI. Those are 2 separate GitHub repos. You can find it on the AWS GitHub organization. And if you do, in fact, start using Amplify and have issues or have features that you want implemented, things like that, you can go just open an issue on GitHub directly. And finally, this is me. Thank you so much for everything. Oh, yes, and questions before I go.
So when you started, you mentioned this is a way to get bootstrapped. Is this like how how you get it up, you show it, but if you actually want to make a real app, you start wandering away from Amplify, you take the code, the cloud formation script and all that stuff with you, or is this really a place where you're going to live your app?
It's an interesting point. So the question is Amplify really just a prototyping tool? Is it something that I'm going to just, an environment that I'm going to spin up just for a while to show my app to get funding and then move on? That's the way I framed it. But no, this is absolutely a tool that you can use to build production applications. You can also customize the things that you've created in Amplify and work against those. Generally, I think it is a rapid way to get started, right? So it's a very, very easy way if you have a solid front-end team as well, that they don't have to go spin up services in AWS themselves or have to rely on a back-end team that then goes and does that for them and grants them access to it. It's a way for somebody building primarily client applications to immediately start doing that with full features of AWS today. But further down the line, I do believe you're probably not going to want to go write the JSON or YAML for the CloudFormation templates that were created through Amplify either. I think it's fine because they're still CloudFormation stacks, just like any CloudFormation stack that you would manage. So in that respect, too, it helps you shortcut to getting a more complete application and worrying less about how do I hook up Cognito and my API layer to make sure that this is a secured API. So again, probably the UI stuff. I've never seen a company put out a production app with a just pre-built UI component. That's not to say that it's not possible. There are very strict standards and guidelines around most companies' UI that it probably warrants like, oh yeah, we'll use the Amplify library under the covers to do the sign-in and the confirm code and things like that, but we're going to build our own, which actually I did in one of my applications as well. I just built a material version of the login. So yes and no is my answer, the long way around. Yes, any other questions? Gotcha. Does AppSync use API gateway behind the scenes? No, I don't believe it does. I mean, it just depends on what you're actually building. The question was, which one is more popular than the other, right? Which we don't really break out the activity of the services like that, but it definitely depends on what you're building, right? Which one would be more useful? I think maybe, and correct me if I'm wrong, maybe the slant of your question is towards which one do I use? Okay, so in that case, if you're building something that relies on real-time data, GraphQL can really help you with that, whereas the API gateway doesn't support that at all. You can't connect a socket currently to API gateway. You have to either use the IoT services or AppSync, right? So a subscription in AppSync can utilize a socket to do real-time data, and that's what you get for use cases like that. If you're just building like a CRUD layer, right? Create, read, update, delete. It's probably overkill for GraphQL, honestly, unless you are working on devices that are really resource restrained and need clear definitions of we're only sending these 3 data fields and we only need to make 1 call, right? I would just say go with what you're most comfortable with, unless you have a specific use case for GraphQL that it can meet. Well, I'm just about out of time, but one more, sure.
So does AWS recommend using Amplify instead of using the service-specific SDK for S3 or Cognito? Suggest that you go for Amplify?
Okay, so the question is, does AWS recommend using Amplify instead of the normal JavaScript SDKs, right? Is that?
Yep.
Okay, cool.
JavaScript or iOS, whatever.
Or iOS, yeah. Actually, the Amplify pieces in iOS and Android are actually built into the SDKs currently. I don't know what the plans are for if they will break them out into separate Amplify libraries or not. But right now, if you go to the documentation, you're still using the iOS SDK. For JavaScript, it's a personal preference, right? If you need to do things that are not implemented in Amplify or are implemented in a different way than you want to work in your application, I would recommend using the Cognito JavaScript SDK. Personally, I have used the Cognito JavaScript SDK in an application, and it's pretty difficult to get started with. Granted, that was about 2 or 3 years ago. It may be easier. But Amplify, I mean, I built this GIF thing in like, I don't know, a couple hours, right? So, and it has full auth. It respects the life cycle of signed in, signed out. It does forget password, and I didn't have to write any of it. So I just dropped in an Angular component, and it just worked. So I would recommend Amplify for sure. I don't know what the official AWS stance is on that. But again, it depends on what you're trying to do.
Any possibility of extending to Python?
To what?
Python?
To Python. I don't know. I don't know. That's an interesting thing. Talk with me afterwards for sure. I'd like to hear more. But actually, we're adding features and services to Amplify all the time. We just added support for Sumerian, which is our AR VR service. It actually uses, AR and VR through the web. So you can have a URL just automatically created through Amplify and things like that. So I'm over time now. I will hang out in the back. You can come ask me anything you want. I may or may not have an answer for you, but I will get you one. I appreciate everybody's attention and time. Thank you so much for having me out.
Thank you, sir. Appreciate it. All right, folks.